Okay, yeah. So my name is Maiwa. I work as an Android engineer with Spotify, and it's actually an honor for me to be the one, to give this talk to everyone. I say a very big thank you to everyone who is here to come and listen to me, talk about Dagger. I can see a couple of familiar faces like Michael Obi. Thanks for thanks for taking time out, to come and listen to me. So yeah, DI is actually a very important topic in Android development and even in software development in general, because of what it helps us to achieve when you're able to do dependency injection. One of which is dependency inversion and testing. So it's quite a very important topic. And in Android development is actually also a very passionate and keenly contested topic in the community as well. You've been following some of the community folks. You see some fights happening here and there. Service locator coin, Dagger. It's actually always very, very passionate topic. So today, it's actually very cool. That we have to talk and discuss about this. And in this talk today, we're just going to be trying to talk about dependency injection before we move into Dagger, because at times some of us get carried away with Dagger a lot, that we think Dagger is actually dependency injection. Like if they ask some of us that, okay, what is dependency injection? The first thing we say is Dagger. But Dagger is actually not dependency injection. It's just a way for us to do dependency injection. So we'll try to talk about these things ground up from what a dependency is. Then we'll move to dependency injection. Then we'll move to Dagger and we'll try to talk about what Dagger really is and how we can use Dagger. So let us just get right into it. Yeah. So what's a dependency? Like I have here in the slide. So a dependency is something, an object that a particular object needs for its own functionality. When I need something from you, then I'm depending on you. So it's very important that we get that concept of what really is a dependency. When we're saying something is a dependency, what does it mean? So it means a particular object needs another object for its own functionality. I cannot function without you, which makes me to depend on you. It makes you my dependency. So yeah, so if a class A uses some functionality of B, then we can say A depends on B. That is really clear. And class B in turns, it's a dependency of class A. So if I depend on you, you are a dependency for me. I'm depending on you. So that's basically what the idea of dependency is. It's really how you think about it when someone asks you to just give an English definition of what you think a dependency is. I depend on you. Then you are my dependency. I cannot function without you. I need something from you. Before I can work, I need an instance of you to work. That's just basically what it is. And as you can see in this diagram as well, we have a class A that uses something from class B, which means class B a dependency of class A, and it means class A depends on B. So that is where the dependency injection comes from. And the whole thing that dependency injection tries to do is to satisfy these things. I need you, so how do I get you? That is basically what we are here to talk about. It's basically what the whole story, what you all know is about dependency injection is. I have a dependency, I need a couple of things, because most times when you are writing your own code, you are going to need a couple of different things. You are going to need code from several classes, probably the way you've modularized your project, the way you've partitioned your project, or some libraries that you've imported. Those are the things that you need for your own functionality. And dependency injection is just how to satisfy that thing. In summary, yeah, so dependency injection is just how to get an instance of what you need, because you need an instance. For you to use an object of a particular class, you need an instance of it. You need to create an instance of it. You must get it somewhere before you can use the functionality. And so dependency injection is just a process where you delegate the creation of that thing. I need something to work, but I don't want to be the one to create it myself. I want someone else to give it to me. So the process of delegating that creating of those dependencies, you want to delegate it to another entity, to someone else. That is dependency injection, because I don't need to care. I only know that I need A, B, and C. I don't want to bother myself about the process of creating A, B, and C. I want someone else to do that for me. And that is what dependency injection is. We know what a dependency is. We know that is what a particular class needs to work. Those are the dependency. Those are what it needs. How does it get those things that it needs? That way, so there are several ways that could happen. I could create myself. I could, look for it myself, which is what service locators really are, setting for service, something that you need yourself. So it's not really you creating themselves, but there's someone that is creating that you can search and request for it. But there's not another part where there's a creator, and you can just tell that creator at some point where you need something to inject this in to give you these things. It's basically what the dependency injection is. And yeah, so the class that needs the dependency doesn't need to care about how the dependency are created. And because you don't care about it, you are not really tightly bound. The ideal thing is because you should not be tightly bounded to your dependency, because this creates some very strong coupling between modules that shouldn't be the case. So you just like a little image as well to show like a particular object. So I need A and B, please. So you talk to dependency injection. The dependency injection does the magic, creates the object for you, then hands it over to you. That is basically what dependency injection is. It has nothing to do with Dagger, at least not at this point. So you can talk about dependency injection. You can do dependency injection without Dagger. You can do dependency injection without a library. You can. It's really not a Dagger thing. It's really not dependency injection equal to Dagger. No. It's dependency injection exists outside of Dagger. Dagger was created to solve a problem with maybe scalability that occurs when you're trying to do your own manual injection. It's not Dagger dependency injection. It will be really nice if if this should be one of the things that we take out of this talk. So a very simple example here, an example of a car and an engine. We know a car needs an engine. So how does the car get the engine? So the car can decide to create the engine itself. It can grab the engine somewhere else, and it can have the engine supplied to it. Probably when you're constructing the car or through one of its methods, you can say, car, take this engine that you need to function. The engine is a dependency for the car. The car depends on the engine. A car cannot function without the engine. So we need to talk about how does the car get the engine? And there are several ways. One of those ways is dependency injection. One of those ways, and that is what we want to look at here. So look at this example, the car engine example. This is not DI. It is not DI because, as you can see, the car is the one constructing the engine. We can see engine, new engine. We are creating, the car itself is creating this engine on its own. And one of the problems is that now the car is tightly bound to this engine. So if this engine is an engine that uses gas, you cannot swap for an engine that is electrical later. You cannot swap for an engine that is meant to maybe run on water later. It's tightly bound. This is fixed. You cannot, it's rigid. It is what it is. You cannot change it. It's one of the problems. Apart from the car, apart from bothering the car with the implementation detail of creating its own engine, this is also tightly bound. Nothing is fixed. You cannot change it. Yeah, so issues. The car is tightly bound. It's tightly bound. You can't supply an alternative implementation. And then, yeah. So it's also, the hard dependency on the engine types makes it difficult to test the car class because it's tightly bound to it. You cannot test it because probably in tests you don't want to use a real engine. You probably want to swap it with a fake engine or with some sort of mock. But with that implementation that we have above, that's not possible because now we have this tight relationship between the car and the engine type. But let's look at this, the DI approach. Now we have a car class that specifies that it needs an engine in the constructor. As you can see, this car does not care. When you start the car knows that it's supposed to talk to an engine and say, engine, just start to do your work. I don't want to know how you're going to give me the engine. You user of the car, you know that this car needs an engine, create the engine and supply it to me. The process of supplying the engine to this car that we have here is dependency injection. You've injected the engine into the car. So we can see here in the constructor where the car needs an engine. And so let's look at this simple main method. You see this main method wants to create the car class, and it knows that a car needs the engine. You see the process of creating this engine here, we've created a dependency already. So this main method creates this dependency, and it passes that engine dependency to the car. This is basically what dependency injection is all about. And the part that Dagger helps us to fill in is to do this, to create this part. to do this creation part and this supplying part as well. This is where Dagger comes in into the thing. I've done dependency injection here. These two steps, dependency injection, no Dagger. No Dagger. I created my dependency when I needed it. I supply dependency to the car. Now car is fully testable because in my test, I can create a fake engine and supply another. So I can supply different kind of engine to my car. Different type of engines. Yeah. So what are the benefits of doing the cleaner code? Since the process of creating the dependency is not tied to the code that uses the dependency. There is no separation. You get some cleaner code. You also get advantage with testability as well, which is huge gain. You should be able to test your code. I saw one code somewhere that defines a legacy code base or a legacy code as a code that you're writing without test. So they didn't define legacy code as a code that you wrote 3 or 4 years ago. No, they said you can actually be typing the code live right now, but the fact that you're not covering it with tests is making that code legacy by default. And I really love that definition. So the fact that DI makes it possible for us to be able to test is a huge gain. It facilitates code reusability as well, because once Dagger takes care of, or once, okay, we're not talking about Dagger now. So once the dependency exists somewhere where you've created it, it can be reused. You can just supply it at different places where that dependency needs to be used. And it's really, really nice to have this in place, especially for a very huge code base. That is where dependency injection really, really wins. And Dagger itself, that is where it wins. For very little, little code bases, might look like you are doing a lot of groundwork, a lot of boilerplate, a lot of things that you might feel are not necessary. But as the code increases, as the code graduates, the complexity increases, more people come, more hands are joining and contributing, code from different places. This is where the BI and Dagger really, really shines. Loose coupling as well, which I think I've already touched. So some DI drawbacks or some things that might want to deter some people to consider using DI is that manual DI. So if you're doing DI yourself manually without using a library, without using a Dagger, a coin, or whatever library, it's tough to maintain. As the code complexity or the size increases, this is really tough to maintain. So it's actually better if you can delegate that to someone. So that's actually where Dagger comes in. Okay, help me do this. I don't want to bother myself with this. I can actually do it myself, but I know that as the complexity of my code increases, this is going to be a bottleneck for me. So Dagger, help me handle it. And then so learning to use some of the DI libraries can be a bit tasking, like Dagger. Dagger is it's not really that tough, to be honest, but at times it can be crazy to the point that even Google themselves, they have to iterate on Dagger. There's a vanilla Dagger, which is actually what mostly I'll be talking about, the vanilla Dagger. At some point they iterated, they gave us Dagger Android. Now there's a new iteration, it. So it's so problematic like that. So learning Dagger at times can be a bit of headache. And then so integrating their libraries into your code is going to affect your build time. So if you compare doing manual DI with using the library, Dagger uses code generation, so which is going to impact your build time. So it's one of the things that some people in the community have against Dagger. There's even a version of Dagger that uses reflection. So they shifted the whole slowness from your compile time to the build time, because reflection too is going to cause some slowness at front time. So you can choose where you want the devil to appear. It could be in compile time, slow your compilation, or you move it guys reflection. Then I'm sure I know there's a version of Dagger. I think most people use that reflection Dagger version for compilation, and they swap it out for code generation at in runtime. But yeah, that exists if build time is really an issue for you. And these are some other libraries aside Dagger, popular DI libraries. We have Dagger, Coin, Coding, Toothpick. Most of all these other ones are Kotlin based. So they are mostly used in Kotlin code bases. And Dagger, it should be said, is not really it wasn't designed for Android, I believe. I'm sure the initial version of Dagger, the Dagger 1, was definitely not developed for with Android in mind. But I think with the iteration movement to Dagger 2, there are some Android parts. Then, you know, with them Dagger Android and the new ILTs, those ones are much more Android focused. But Dagger is not really an Android library; it's a Java library, which means it can be used in a Java project. Okay, good. So now we've covered the basics. So I'm sure by now we know what a dependency is. We understand what dependency injection is. We know that dependency injection is not. We know that dependency injection is not Dagger. So that is really clear. So when we're talking about dependency, when we're talking about dependency injection, and we also understand the reason why we need Dagger. We understand the role that Dagger is coming to fill in this whole thing. We understand the reason why we even have to talk about dependency injection in the first place, because this background knowledge is really going to help us to understand what Dagger really does and the advantage of we having it. So let's go. Let's try to look at Dagger now. Dagger is actually based on this GSR 330 specification. You know, I will show what the spec looks like in the next slide. And Dagger uses code generation. It's annotation based, heavy on annotations, and what that means is that those annotations, you know, get interpreted, and you know, the Dagger compiler is used to generate some code for you, and that is what Dagger is really the entire concept behind it. It's a GSR 330 spec, and it uses code generation. So let's move on.
Samira,
yeah.
Sorry, just before you go on, I want to reiterate that we have on the chat a link where you could share your questions and contributions. So everyone should check it out. It's a site, sli.do. Then use that code to drop your questions or contributions. So towards the end, we could share all the questions and maybe run through them and discuss again. Thank you. Please go on.
Okay, nice. So this is what the GSR 330 spec looks like. We have the at inject, the named qualifier, provider, and this qualifier annotation as well, the scope, single thing. As you can see, these are the things that out of the box GSR 330 provides and which Dagger implements. So Dagger provides all this out of the box for us, and we're going to see what some of these actually means, how to use them, you know, further down this talk. So the Dagger concept, the main thing that we need to focus on, that we really need to understand about Dagger, one of them is modules, and the module annotation is used to, so you use it on a class that is used to provide dependencies, because we know what dependencies are. We know these dependencies needs to be provided somewhere. Like we saw in the example I did previously in the main method, that is where I'm creating my engine object that I pass to the class. So this could, you know, be like a module, for example. But in Dagger, these are separated. So there is a separate class that you create called a module where you actually create your dependencies. And so I provide this one annotation that you use on functions. So at module, you use at module on a class, then you use at provide on the functions, because functions are what you are going to use to create your dependency. The return type of these functions are the dependencies that are actually needed. So what this at provide function is returning is actually the dependency that is probably needed somewhere. So at provide annotated functions are usually located in module class. So at provide and module, they go hand in hand. So once you have a module, you have a class that you annotate module. What you expect to find in such a class are providers, and each of these providers are annotated at provides. And the return types, so these are methods that return something. They return something to you. So the return types of those at provides are dependencies. In the car example, so we are going to have an at provide that returns an engine. The return type of that function is going to be engine, and that at provide function is going to be living, is going to be located inside an at module. And I'll still talk about this later again, but we should also know that you don't really need a module or a provider to make a particular class available for injection, to make it possible for you to inject or to make Dagger, you know, supply a dependency for you. Just creating a class and annotating the constructor of that class at inject makes that class available. I'll probably shed more light on that later. So we have at inject. So we've talked about at modules, how to create a dependency. Then at inject is what you use. You use it to annotate either the constructor of a class or you annotate a field. And this is what you use to tell Dagger that you need a dependency. I need this, give this to me. The providers and the modules, they take care of creating those things. They are there, they've been created. So how do I request for those things? Is with at inject. That is how I say, give me this dependency. And Dagger already understands what to do once he says that. And we also have the components. And then we have an annotation for that as well. So which is at components. And these are used on interfaces. And this is what actually binds everything together. Because now we have two things. They are living their own separate worlds. We have the modules, they are providing all these things that you need. And you are sitting there somewhere saying, okay, at inject, I need this, I need this. Then component sits in the middle. So it's one that takes the module. And then this is actually where Dagger code generation actually kicks in. So Dagger looks for this, these component interfaces and generates and does the code generation for you. And binds, it links the two. It binds where these dependencies are created to where they are needed. And Dagger actually generates, okay, we'll get to that soon, but just a bit of in-depth analysis on some of these things. For the modules, we already know that a module holds the functions, right? And this is how dependencies are provided. We know the modules hold functions, and these functions return types are the dependencies that you need. Yeah, the functions in the module are annotated and provides, and then I provide annotated functions. So this is also very, very important to stress a little bit. So these are provide functions. They can also have their own dependencies that Dagger needs to fulfill, because it's possible that when you are creating your engine, so imagine you have a provide function for your engine. Probably the engine also needs some other things. Before you can construct an engine, maybe the constructor of the engine takes like 3 or 4 other parameters. So the engine also needs some other 3 or 4 things before you can even construct it. You can declare those things in the parameter of that function. It's a function. Like all other normal function, you can take parameters. So you can pass those things in the parameter. And Dagger itself will know that, okay, this provider that wants to provide this engine also needs, the engine itself is a dependency. Engine itself needs other dependencies that is specified in that parameter. Dagger, as long as you've provided, there's a provider that provides each of those parameter types, or the classes of those parameter types have been annotated as inject, Dagger knows to look for them and supply them to that function. So a function that is a provider can also need some other things. That is the point here. Can also need some other things, and you can specify those things in the parameter of that function, and Dagger knows what to do. So let's look at an example for a model. Look at this network model. Right now, this is just a normal class. This has nothing Dagger, apart from the fact that I just named it model, which is just method name. So how do we convert something like this to a Dagger, to what Dagger understands? First thing, like we said, we need to annotate this model. So this makes this a Dagger model. But as it is right now, this is just a Dagger model that is not doing anything, it's not providing anything, despite the fact that we have an OKHTTP client and we have a retrofit. How do we now make this module provide dependencies? We just come here and annotate these 2 functions and provides. And this is it at the very basic level, without talking about some other things, some other Dagger, things like maybe scoping and the likes, qualifiers and all those things. At the very basic level, this is it. Like this can actually work. This is a module that works. So we've talked about how to provide dependencies, right? And we'll see an example of a module. So how do you request for these dependencies? Like we've already I've talked about it as inject. So you use this annotation in places where you need those dependencies. So those things that you've already declared in your module, so the places that you need them, you use this as inject annotation in those places. And yeah, so this can be used on a constructor and on a field. So you can either annotate a constructor or you annotate a field. So you can't use at inject on maybe an interface, for example. No, but you can at inject on a constructor class. You can't even at inject a class. You have to at inject the constructor of the class, and you can also use at inject on a field. And I should also mention that if you want to annotate, you can only annotate one constructor of a class at inject. So if you have a class that has multiple constructors, only one of the constructors can be injectable. So that is also very important for us to note. So only one of the constructors can you annotate at inject. Okay, yeah. So we have constructor injection, field injection, depending on whether you annotated the constructor or you annotated a field. So what else? Yeah, like I mentioned earlier, a class whose constructor is annotated at inject, that class is also available to be injected without a provide. So you don't even have to create a provider for it. So once you've annotated a class, the constructor of a class at inject, then you actually do not need a provider for that particular class. So we should know that as well. But we should also understand that if you annotate the constructor of a class at inject, if that class is a class that takes, if the constructor requires some parameters, those parameters must be injectable. Dagger must know how to supply those parameters. So you can't just, skip your provide and just come to your class, annotate it at inject, and expect Dagger to be able to inject it because I said once you've annotated the constructor of the class, then the class is available. You need to also look, okay, these parameters that this class needs, can Dagger provide them? Or maybe if the class does not, if the constructor takes no parameter, that is fine. Then you're not constructing anything. Then you can just go ahead and annotate the constructor of that class at inject. Then you can inject it somewhere else as well. But if it's a class whose constructor takes parameter, you need to look. There must be providers for those different parameters. Dagger must know how to supply them. Then you annotate it at inject, and that is fine. Dagger can create that class, and that class is now also available to be further injected downstream. So let's move on. Look at this example as well. So we have this GitHub API thing that needs a retrofit instance. So this could be something you have in maybe your repository, or maybe some use case or some presenter somewhere that needs to use this GitHub API. But this, it has a constructor. Now you're not requesting for anything. Basically, what we have here is just a class that needs a dependency and does not want to care. The user of this class is not going to be the one to supply this dependency. But because luckily in this project we are using Dagger, so we can use Dagger to say, Dagger, give me this thing by just annotating, by annotating this at inject. But the point is that before this is going to work, this retrofit must already be providable. There must already be a provider in a module that supplies retrofit. This is why this whole thing that I have here is going to work. But this is just basically how you request for a dependency. So there's already a provider for this that you provided in a module. Then you can annotate this as inject, and that guy is going to be the one to inject this to supply you this dependency. And now dependency injection, that thing we are talking about, that buzzword dependency injection, has taken place. And the example here, we use constructor injection. For field injection, this is basically what it looks like as well. So this is a field. This presenter here is a field. We have another field here for the shared preferences. Just need to annotate it at inject. And I missed one part here. So then in your create, there's going to be somewhere where you get the components. No. Either you get the main app component, or you get or maybe a subcomponent that you are going to use to inject these dependencies. Then one key thing, so between field injection versus constructor injection, I know I've seen, I've worked in a couple of code bases where I see things like this, and it really just looks so funny. So you should use constructor injection for classes that you own. So if you are creating your own classes, you are creating probably some presenters, some repositories, a use case, something manager, something provider that you are the one creating. Always use constructor injection. Always use constructor injection. Field injection is meant for things that you are not the one responsible for creating. Probably something that comes from a library or Android framework classes itself, activities, services, fragments, these are things you are not the one, you know, you are not the one, you don't have access to the constructor. But things that is your own, that you own, that you have access to their constructor, always use constructor injection. Like always use constructor injection. It makes your life easy when you want to test, because then you won't require Dagger in your test. Once you are testing a presenter or repository and you actually need Dagger to test such, it's a smell, something is wrong somewhere. And the only reason why you're going to need Dagger in your test is because you use field injection in your own presenter and your repository. You use field, you created those things there, those dependencies that you needed, you put them there as a field. The only way you can supply those things in test is to use Dagger. But once you did not do this and you do the actual right thing because you own it, put them in your constructor. Use constructor injection. So it's key. Let's know when to use constructor injection versus when to use a field injection. Very key. Yeah, so we've talked about the modules, we've talked about the at inject, and now components, talking about it again. Like I've said earlier, you know, this is the glue. It joins the providers with the people that need the dependency consumers. And it's used on an interface, unlike the other ones where they are used on constructors and things like that. Your components is used on an interface. And Dagger generates, we know that this is where Dagger comes in. This is the entry point for Dagger to say, Dagger, come and do your work. So it's going to generate a file for you, which is usually Dagger plus the name of that component. So for example, if you have an app component, then it's going to be Dagger app component. So that is what Dagger is going to generate for you. And that is what you are going to use, you know, to build your component. Yeah, and a method needs to be created inside a component class. In classes where you need to do field injection. For constructor injection classes, you don't need this. But in places where you need to inject, you need to do field injection, then you need to actually create a method in your component. For example, for your activity. That's why in most, I'm sure probably a couple of us, you know, this is actually not our first time of hearing Dagger. We'll maybe have some experiences. You see that in some app component, you see some functions inject into maybe some activity, to inject into some fragment, to inject. The reason why that is there is because you want to do field injection. I need to get those components, you know, to inject dependencies into those fields. If you're using constructor injection, that is actually, you actually do not need that. So in your component, you know, some of the functions that you see inside components, either you're trying to expose some dependencies for dependent components down the stream, or you are trying to inject to do field injection. So you are creating methods, you know, to inject to do field injection in those classes. So basically, this is also what the component looks like. So you're going to have an interface, then a component, then you're actually going to supply modules. So these are components. It's an annotation that takes some parameters. So you use this module to say, okay, this component, this and this and this are the modules that you are going to use to satisfy dependencies. We know that this is a glue, right? We have the module somewhere. We have the consumers of the dependencies somewhere. So when you're creating a component, you need to tell it, okay, if someone is requesting for the dependencies, pick those dependencies from these modules. You can actually have several long lists of modules. And you yourself, based on what you are doing, you logically separate your modules based on how it makes sense to you, based on, you know, some app modules can contain something, maybe like context, shared preferences, maybe some things that I think are, at least maybe the way I do it, that's sort of tied to the Android API. If I need to do some shared preferences, I need to provide work manager instances, I need to provide all these manager things that are tied to the context, that are tied to the Android SDK. If I tend to put such a thing in the app module, then the network module can contain some of your network things, your retrofit things, your APIs. Then you can even create a separate module for database where, you know, you want to return some room DB things, you know, based on how it makes sense to you. That is how you divide these things. You could have put everything in one single module, no problem. If it makes sense to you that way, fine. But the separation we are seeing here is just logical separation. It's not a must. You have to create these things. These things are not, they don't mean anything. They're just names. App mode is just a name. You can rename it whatever you like. But the separation is logical based on, you know, the sense, how you want to relate with your code. And like I said, so now we want to use this app component to inject into main activity. So I need to create a function inside this where to say, okay, so once I have an instance of this app component, I can use it to inject, to do field injection into my activity. You can also have sub-component builders. I sort of skip that here as well. So you can have a component builder rather. So there are sub-component builders, but there is the component builder as well, where you, or like a factory. So you can create like a factory interface or a factory function that you use to generate an instance of your app component. So let's move on. So somewhere in your custom application class, you are not going to have something like this. So like I said, Dagger is going to generate Dagger plus the name of the interface. So you're going to have something like Dagger application component, then you call the builder. Like if builder is going to be generated for you anyways, or if you have a custom component builder, you call that builder, then you pass an instance of the app model, then you call build. So this, in most cases, this is usually in your custom app class. In your own application class, the class that you created that extends application, you have something like this there. So you create the root app component, you root it there. And everything is now going to work from where we've been going. So once you have this whole setup complete, from your modules to your inject to your component, and you create an instance of your component in your custom app class, the entire setup that you need for Dagger is complete. You actually have a complete setup at this point. Every other thing that comes afterwards are just some intricacies or some ways, to manage things better, or to manage things better, to make your code base much more scalable. At the basic level, at the base level, this is it. This is actually it. All the other things, scoping, qualifiers, sub-components, dependent components, multi-bindings, this and that, those are just optimization. Those are just some ways, to do things in a much more scalable, in a much more better way, so that you don't have just one long, spaghetti thing dumped somewhere. But at the basic level, this is how you set up Dagger. Yeah, so in summary, the modules and provides, these are the mechanisms used to provide a dependency. The inject, this is how you request for the dependencies, and the component serves as a bridge. So once we have this idea, the mental model, this is a mental model of Dagger that I want us to build. The modules and providers. So when you're running your Dagger code, the thing is telling you it cannot find a particular binding. The first thing that should come, if it cannot find a particular binding, it is because there's no provider for it. Because that is actually what most of the issues with us using Dagger. You run Dagger and you see something is capturing someone, then you see a long list of error in your log cart, and you're all over the place. Just try to relax and take a step back. Try to understand it. These are like the thing. Either something is wrong in the module, or something is wrong where you're injecting, or something is wrong with the component. These are like the three places to look at. Am I providing is there a provider for this dependency? Am I using the right scoping? Those are the sort of questions you should ask yourself when you run into a Dagger issue, because it usually revolves around these things. You are trying to inject something you've not provided. You are trying to use a component with a lesser scope with a lesser scope in another component with a bigger scope. These kind of things are what usually causes most of these issues. So let's take this a step further. So we've talked about the basic, the things that you need. You can do Dagger without using qualifiers, but then these qualifiers helps you because you run into some cases where you actually need qualifiers. So imagine a scenario where you have a provider. Maybe you have a provider that provides a string, and that string is maybe the base URL of your app. And you have several URLs because your app is connecting to, you have a staging URL and you have a production URL. These two URLs are strings, because the way Dagger knows what you want to inject is by the return type. So which means you are going to have two providers that return string. So when you, at your injection point, when you say I need a string, how will Dagger know which string you want? Maybe you even have a couple of others apart from your base URL, probably another string for maybe an API key, another string for something that you are injecting at different places. You have several strings. How will Dagger know which string exactly, which of these strings that you are providing do you need? This is where qualifier comes in. because this qualifier annotation is treated as part of the method signature. So with a qualifier, so it's like you're having an overloaded, like the way we have overloaded functions in you know, we can have in Java also well, it's less pronounced in Kotlin because you can have default function and all that. But the way before Kotlin came, the way we used to do it in Dagger is you overload a particular function. Maybe one is going to take one single parameter, then you can have the same function with the same function name, taking 2 or more parameters, another function name, taking 3, you've overloaded that same function. This is what this qualifier actually help us to do. It overloads that function with these qualifiers that you add. So that's why the fact that they have the same return type, string, with the qualifier, the signature changes. So if you use the qualifier to provide, you also use the qualifier to inject. A very lame or basic way to look at it is maybe just you can look at the qualifier as maybe a surname. My name is Mayowa. There are several Mayowas. If you shout Mayowa, like 10 people will answer. But if you say Adeke Mayowa, most likely it's only me that will answer. So that is actually really what the qualifier is. It sort of changes the signature. And at named is a qualifier. This one is provided out of the box. You can create your own custom qualifier, but you have this at named provided out of the box by Dagger. So an example, so you have 2 OKHTTP clients, for example. One is meant to use cache, then the other OKHTTP clients are not using cache. Maybe you want to use that other client in your Espresso test or something. You don't want to cache, you don't want to do anything. So the way it works is you use this named qualifier. Look at this thing here. Named, then you put a string, cached, at provides. So you use this named qualifier to say, okay, I'm naming this one. This is the cached. Then this is the second one, uncached. They are both returning OKHTTP. This is the type they are both returning. But because you've already used this named qualifier, you've separated, the signature has changed. So at the point of injection, also, you need to specify which one you want. If you remove this named, Dagger will not know what you are looking for. You are going to have an error because now you are trying to inject an OKHTTP client without a qualifier. Dagger does not know. So, but by saying named, cached, and of course, you know the name has to match. So if you have a typo here, of course it won't match. It won't match what you have here, cached. It will not match. So at times you can actually declare these strings in a constant file somewhere, and you reference that constant so that you don't make mistakes because it matters. So you can't use cached here and come and use another name here. Dagger would not know. So at the injection point, this is what you do, which makes Dagger now understand which particular OKHTTP client type you are trying to inject. And then custom qualifiers as well. So apart from the name qualifiers, you can create custom qualifiers. The purpose of the custom qualifiers is that, you know, apart from, you know, this whole string thing that you have to manage with named qualifiers, you have to manage all these string names everywhere. Custom qualifiers also help you to create something much more meaningful. You can create your own annotation. It's much more meaningful. So it makes it, when you're looking at the code, it's much more meaningful to you than using the named qualifiers. That is the purpose of all these custom qualifiers. And the way you just go about it is to you create a custom annotation. And for this OKHTTP client example that we have, yeah, so you create a custom annotation, and it's just a normal annotation, the way we create annotations, and it just annotates it with at qualifier. So the at qualifier annotation, you put it on that custom annotation that you are creating, which is basically what we have here. So for example, if I want to create custom annotations for my OKHTTP client, I'll just say annotation class. This is the way we do it in Kotlin. In Java, you would have done public at interface, then the name you want to give that annotation. Then you have to annotate that class with at qualifier. Then you need to tell it to retain it at runtime. So at runtime, you want this annotation also to be present at runtime. So this is how you declare it. For the other example that I sort of talked about, the URL one for strings, you can also create your custom qualifiers. This one that goes to maybe staging URL, production URL, API key. That's what the name of the annotation is going to be. Then you use them the same way you use that named qualifier. So instead of having named at cache here, I've already created this cache client, this annotation. So I just need to apply that annotation directly. And in this case, you don't need to supply any parameter or any string or something. And now this sort of makes more sense. Like if you're looking at the provider method and you see that that provider method is annotated at production URL, you know it's production URL. By seeing that annotation, I think that is clearer. That is, makes more sense than at named production URL. Once you say at production URL, at cache client, then the uncached one to at uncached client. So it sort of makes more sense. It makes it create something that is much more meaningful, that you can relate with more. So, we've gotten qualifiers out of the way as well. So let's now talk about scopes, which is also a very key thing in Dagger. So scopes is what you use to manage the life cycle of your dependencies. Because without scope, it's possible that without scope, you really don't want to create all your dependencies when your application starts. Probably there is a particular dependency that you only need when the user is already logged in and they navigate to maybe their profile page, or maybe it's an e-commerce application. The dependency is only needed when they want to check out. But you've already created that dependency at the beginning. This is already sitting down there in memory, consuming memory for nothing. So this is where scopes, and again, it's also possible that you need a single instance of something within a particular scope. There are some things that you need only one instance of those things application-wide. There are some other things that you need only one instance of them within a particular, maybe for each activity. I want each activity to have their own copy of this, this, and this. But as long as I am within that activity, if that activity has several fragments, I want all those fragments to share one single instance of that thing. But each activity have their own different instances. And it should also be mentioned that scoping also comes at a cost. It's always advised that only add scope on your app providers if you know that thing that you are trying to provide, maybe if it is expensive to create, then you can scope it. Because like I said, what scoping ensures that only one instance of a certain thing exists within a particular scope. So if that thing is expensive to create, of course you don't want to be creating every time, because an unscoped dependency, like we've been seeing so far, for example, it has no scope, this OKHTTP client. It means every time someone says at inject, give me OKHTTP client, every time OKHTTP client is requested for, a new one is always going to be constructed. So if OKHTTP client is so difficult, maybe it's hard, it takes, it's actually a very complex class. You want to create it once, and everywhere it's being requested for, you want to supply that single instance that you created just once. So that is one of the things that scoping does. So it ensures that a single instance of a dependency exists within a certain scope. And when that scope expires, that dependency is also destroyed. So we have the singleton scope. The singleton scope is the largest scope. The singleton means application-wide. As long as this application is running, I want just one single instance. An example of things that should, and most of the things that will be in maybe your app module or that you tie to your app components, most of them usually have a singleton annotation, because you only want one single instance of those things. My room DB, for example, I don't want to be creating a room DB every time, just one. So wherever, whether it's at checkout or at login, or when you're adding items to your carts, or when you are checking, you are retweeting something, or when you are liking a particular thing, I only want one instance of this thing wherever I am in the application. Those are the things that you put singleton. Those are the things that get tied to your app component. Singleton, like the name implies, one single instance. And this one, the singleton annotation is available, by default. You don't have to create it. Then some other scopes, like maybe activity scope, service scope, and this activity scope thing is also just a name. It's not a keyword or something. You can create some custom scopes by yourself. And what it means is that anything that you annotate with that scope, because a scope is always tied to the life cycle of something. So you can create a custom scope and a custom component for maybe after the user has logged in, the login activity can have its own scope that you annotate activity scope. So whatever dependencies you are supplying with that activity scope, those dependencies will not be available before the user log in. No, they won't be available. But after the user logs in, those dependencies get created. Once the user logs out, those dependencies get removed from memory. It's still possible that, of course, the user has logged out, but the user is still inside the application. Maybe they're able to do some other things. The dependencies that are available application-wide, those ones will still be available. But the one tied to some other smaller scope things, once that smaller scope thing is out of scope, those dependencies get freed because you actually don't want to clog your memory. As a mobile application developer, we are working in a very constrained environment that we need to worry about so many things: memory, battery life, network connectivity, and all sorts. So an example of two dependencies that you can see, one is annotated as singleton, the other one is not annotated singleton. So the one that's annotated singleton, just one single instance is going to exist. So every time you request for this retrofit instance, for example, just that same one, that same single instance is going to be used. And a module that is annotated, with a scope annotation, also go hand in hand with a particular component. So you must use it hand in hand with an annotated component, and the annotation on the component must match the annotation on the modules. So this is also one of the things that might cause some problems with using Dagger. You cannot use a module that you annotated the provider at activity scope. Now want to include that module in a component that is singleton. It's not going to work because singleton is application wide. It's a larger scope. You can't put a smaller scope something in a wider scope something. You get? Our time is almost fast spent. So I'll sort of just try to run through what I have left, which is just talking about because the concept of scoping, you can see that since I started talking about scoping, I've been talking about dependent component and subcomponent. They sort of go hand in hand. So the singleton scope is one that goes with the app component, but by the time you now get to scoping, you now need to start talking about, you need to start worrying about dependency, dependent component, subcomponent. You need to start creating subgraphs, and that is okay. So they're just talking about how to create a custom scope. Just same way you create an annotation, but you annotate it at scope. For qualifiers, you annotate it qualifier, but for scope, just annotate it at scope. This as scope is available in the Java Engine. Dagger provides that one. And yeah, so you can just annotate maybe a presenter activity scope. So it's tied to life cycle of an activity. Scoped objects, so I've mentioned it. So they live as long as the object that they are tied to, as long as it exists. Then if it's the scope provider and the component, you include a provider, a module in the component, they must have the same scope annotation. So they must be within the same scope. You can't carry activity scope and put inside singleton scope components. It wouldn't work that way. So the last most important thing that I need to talk about is dependent component and subcomponents, because these are the way that you're going to actually brings a lot of gloss to your scoping. This is the way you achieve the scoping thing. You need to create some subgraphs that only exist when one certain part of your app, when your user gets to a certain part of your app, and when the user leaves that part of your app, you want those dependencies, you want that thing to go out of scope. So there are two ways to achieve that. You can either use a dependent component and a subcomponent. They actually, they do the same thing, but the way Dagger generates code for each of them is different. For a dependent component is different. For a subcomponent, is also different. Although I think Java generates a much more optimized code when you use subcomponents than with a dependent component. But we'll see how to do these things. I think I've mentioned some of this before. So a dependent component, the way a dependent component is just like a normal component that we've talked about before. It's a component, but you annotate it as component annotation, just like every other thing. But for a dependent component, you need to also specify in its body, you need to specify the list of components that it depends on. A dependent component can actually depend on more than one component. So you need to say this component, you annotate it as component. Then in the body, you say I'm depending on this and this and this and this and this other components. And it's also important, the parent component we know that a component holds the modules. The modules are providing some dependencies. So if I'm a subcomponent, and I'm depending on the parent component, I'm a dependent on a dependent component now. I'm depending on the parent component. The parent component must explicitly expose the things that it wants me to give to my own, to other people that depend on me. So we can look at this thing as like an hierarchy. So I have someone above me, but that person above me have to list the things that I'm able to inherit, that I'm able to supply to those that are below me. That is basically what the relationship between a dependent component and a parent component is. The parent component must explicitly say A, B, C, D are available for you to give to your own people that depend on you. And we've talked about scoping. So a dependent component cannot have the same scope, must have a lesser scope as the parent component. So let's look at this. So we have this feature component. This component, we are using it to inject into a certain feature activity. Then it uses its own module that supplies some dependencies for it. So once feature activity comes into scope, the dependencies in the modules are created. Once it goes out of scope, the dependencies are destroyed. How do we say this depends on a bigger scoped module? By putting these extra parameters. So we say dependencies is equal to, then we supply a list of dependencies that this depends on. So it could actually be more than one component that we're depending on. And we also need to annotate it with a lesser scope something. So now activity scope. So this is not going to be available as long as, and all the providers in this module, this feature module as well, must have been annotated, either not annotated, which means, just give me a new instance whenever I request, or annotated activity scope, which means I want only one instance to exist. And like I said, either that thing is so difficult to create, or that thing holds a particular state. So maybe you have, for example, imagine you have a class that holds a counter, that holds a state, and you want that counter to be consistent. Maybe when you click on one thing, you are incrementing something in that particular counter. If you are getting new instances everywhere, those new instances are going to be starting from counter 0 every time. But once you've annotated it as maybe activity scope or maybe single thing, everywhere you inject it, that state is maintained. If you increase the counter in some deeper level activity and you inject it in another place, you still get that same counter with the same count. So how do we now create? Okay, yeah. Before we get to how we create the dependent component, like I said, the parent component needs to explicitly tell what the dependent component can inherit. So in this case, my dependent component is available to pick retrofit from me. You are available to pick OKHTTP, and you are available to pick shared preferences. I'm exposing it to you. So you in turn can give it. So once you come into scope, you yourself are guiding, you're in a particular scope. So you can supply it to maybe some other class or some other fragment that needs this dependency. They must be explicitly declared from the parent activity. And the way you just create it is you create dependent components. Once you have an instance of your app component, of your parent component, you just supply it as a method. So Dagger generates the fact that you created this, that you have this dependency app component thing. Dagger is going to generate in the builder, it's going to generate a method of that same component name. So that you just pass an instance of that app component, you pass it. And it sort of, and if you think about it, it now sort of makes sense. The dependent component will now hold an instance of the app component. And you know that because you've declared these functions, because you've declared this, if I have an instance of app component, of course I can say retrofit and it will give me retrofit. I can say OKCCP and it will give me OKCCP. I can say share preference because these are functions. So which is once you have an implementation of this interface, you can call these functions. So you can already see why this needed to be declared before the dependent component can have access to it. Because once you have an access to this, you are passing an instance of that app component to your dependent component. It holds that instance and it uses that instance to access those dependencies in its own scope. Very fast, subcomponents. Subcomponent does not use that component annotation. So there's actually a separate subcomponent annotation. And then a subcomponent is inside the parent component. In this case, the parent component does not need to expose anything because it's like an instance of this subcomponent is held. So imagine you create a class and you create a subclass inside that class. That subclass also have access to the instances to the field declared in the parent class. It has an implicit reference. You can already reference them. That is the relationship between a subcomponent and a parent component. A subcomponent is embedded inside it. So whatever bindings are available in the parent component, I also have access to those bindings, which makes sense that a subcomponent can only have one parent because it's embedded. You can't be embedded in plenty of places at the same time. I can only be embedded inside one. I can only be declared as a subclass inside one particular class. You can't be subclass here, subclass here, subclass here. No, you can only be subclass in one place. So that's why subcomponents can have only one component, only one parent, unlike a dependent component where you can supply a list of components that dependent component is depending on. And in the parent component, you create a getter, because that getter is what you're going to use to get your subcomponents. And like I said, I've already explained this. The subcomponent is inside the parent component, which means it has access to all the bindings. So example of this as well. Subcomponent is probably supposed to be activity scope. Subcomponent with its own module. You can use subcomponent to inject into this. Then let's see what happens. In the parent component, you have to declare this function. So this function could actually be anything. So this plus feature component is just a function name. You can give this function name anything. Then the module that the feature component needs. But basically, you are going to have a function in your parent component that returns your subcomponent type. That is because this is what you are going to need to get an instance of your subcomponent, and which is this. So once you create the way you create the subcomponent is, you have an instance of your parent component and you call that getter. You call the getter. Probably in your feature activity, you call that particular function that you've created, plus you pass the module, then it returns an instance of your component for you. Then you can use it to inject, you can use it to inject into your main activity or your feature activity or whatever where you need to perform the injection. Think yeah, we're almost at the end of this. Then the way you add Dagger to your project, basically. So you add the API, you add this API to include the Dagger, the Gradle, this thing for Dagger. If you are using Java, you also need to use annotation processor to include the Dagger compiler. And if it's Kotlin, you use capt. Of course, we know that. Then you need to have added the capt Gradle plugin and all the other things we need to use capt. It's basically how you add Dagger to your project. So some tips as well. Always try to use static provides, because Dagger generates. This is for Dagger to generate a much more better looking, a much more optimized code for us, because at times we also need to help Dagger to generate better code. So always use static provides, as long as basically what it means is that let your provide function be static. That is, if you're using Java, let it be static functions. If you're using Kotlin, put it inside an object. So object is usually always static. So let your modules classes be objects, so that you have just a single instances of your provides. Then always use binds, although I didn't in this talk, I didn't talk about bind and bind instance and all that, but maybe we probably have come across this, or maybe we'll come with something that will actually get to be exposed to after today's talk. But at bind, so you might probably, or maybe something you've already done or something you've seen in a code where you have an interface and you have an implementation of that interface. Then you now have a provider method that returns the interface type. For example, let's take a list and an array list, for example. Then so the interface, the provider is returning a list. Then in the body of the provider, you just say return array list without doing anything. That is not, you're not even taking any parameter in the function that's returning the list. So you just have an interface type and now returning the implementation of that interface. So instead of having a provider for that, use binds. Dagger generates a better code for when you use binds. So you can just say binds, which means binds this. So basically you create an abstract function, you annotate it at binds, and you say when you're looking for when this interface type is being requested for, supply this input. I wish I can actually just show some line of code to demonstrate this. But also one key thing as well is to use JVM suppress wildcard when you're injecting generic types. At the base level, we might not really come across a case where this is actually important. But when I start to do Dagger multi-bindings, you are injecting probably a map of something, you are injecting a set of something, this can actually come and bite you in the foot. You probably have come across this if you try to write a custom injector for maybe you're creating a view model factory where you have to annotate some things, bind into maps. It's a key thing to note. So whenever you're injecting like a generic type somewhere, always remember to use JVM suppress wildcard, especially with Kotlin. Most of these things applies to, some of them apply to Kotlin code. And yeah, so in Kotlin, also be mindful of your provide functions. This is also very key. I'll just do a very fast explanation. You know, in Kotlin, the type can be inferred, right? So you can probably you want let's say you have an interface. Maybe the interface is a cache interface. So you now have in memory cache, you have DB cache. You know, you can actually declare a function where, so you declare a function that returns a cache, and you did not put the type. You did not put the type of that function. Kotlin allows that. You just say the function name is equals to new or is equal to memory cache. What's the type? The type that you're actually putting in your Dagger graph is that actual memory, that actual in-memory implementation. So it's actually possible that what you wanted is the cache, is the interface type. But because Dagger is going to infer the type for you, Dagger is not going to infer the parent type. It's going to infer the particular type that is seen. So if you are returning, if you know that you don't want the implementation type, which is the memory one, to be the one that is in your Dagger graph, then explicitly put the type and say your function name, put the type, cache is equal to, then you cannot put the subtype. You cannot create the subtype. So which means what you're now putting in your Dagger graph is the parent, is the interface type, not the subtype. So we need to be careful about that. So I don't inadvertently, knowingly just put a wrong type into your graph, especially with this type inference in Kotlin. And then this is also one important thing as well, like expose only what you need from your Dagger modules. So probably most of us even have this setup where now maybe network module, for example, you're going to have a provider that provides retrofit, a provider that provides JSON, a provider that provides, so you have all these long lists of things, then you get to retrofit, then you get to cache, then you get to the part where you're actually creating your actual APIs. You see, those of these other dependencies that you created, they're actually only used by maybe the retrofit. You're creating all those OKCTB, provide cache, provide this. You are using them to create your retrofit, but you actually don't need to expose those other ones. They don't need to be exposed outside. The retrofit is probably the only thing you need to expose. It's the only thing you will need to use somewhere. So those other ones that you don't need to expose, they can be private. You don't need to expose those things. So just try to expose the things that you need from your modules. The only thing that should be public, only make things that should be public. The other things probably are just helper to create your main thing. Those don't have to be public. And then, yeah, so these are two things that were not so mentioned in this talk. Dagger Android Youth. It is just pretty much just about a week or 2 weeks old. Dagger Android was just sort of created to make it easy to use Dagger with Android. But the problem is it just came with its own bottleneck, with its own new set of annotations that you have to learn, contribute Android injectors, and it actually just only helps the creating of components. So the idea with Dagger Android is that each activity must have its own subcomponent, and Dagger Android just comes in to help you to make creating a subcomponent easy. But it sort of comes with a lot of having to relearn or learn some new things, which a lot of people were not so happy with. And it sort of although it covers it uses the concept of scoping a whole lot, because they create some custom scope and custom components for you that you can just come and use out of the box. And it covers, most of it's good to understand this vanilla Dagger like we just went through, so that you understand what it is really trying to do, because it does a lot of magic for you out of the box. You don't have to sort of declare a component anymore. Those components are generated for you. The way Dagger Android was generating subcomponents for you, with it, they already have components generated for you. You only need to create modules and say, let this module be in this already generated components. But it's worth taking a look at these things, and maybe we could maybe have a talk sometime to talk about some of these, maybe Dagger Android or IoT. And yeah, so that's it. Some important links to look at. You can look at the Dagger on GitHub or Dagger.dev, which is the documentation for Dagger. And then Google themselves, they have this Dagger Android thing that we can also look at to maybe get some more understanding. Yeah, I think I took more than my time, but so
And
that's it.
thank you very much, Myra. Very insightful. There are a couple of questions. Yeah, so we'll get right into it. But before we do so, I would like to just say that we have a poll. I know I announced that we had a poll to fill. It's a set of 3 questions, very easy questions, basically just to get feedback and find out how we can get things done better. So I'll be launching it now, and please just endeavor to fill it before you leave. Then once we do this, we'll head over to the questions. Yeah, so launching now. So let me share my screen, or okay, let me just read it out there, because you may need no, never mind. You may need to make reference to some of the
The slides, huh?
yeah, some things on the slide. So I have about
very great. Can you hear me?
Yeah, I can.
Okay, you want to mention the questions now, yeah?
Yeah.
Okay.
Okay. Yeah. So first one is when is the best time an Android developer could start learning DI? That's the first.
So how do I answer this? Recently I took like a couple of people that are just trying to get into Android development. I sort of took them into like teaching them how to program Android, and in the course curriculum I included dependency injection. And after the topic was treated, some of the feedback I got was that okay, this is sort of too high level. But the reason why I included it was that in the industry, you are actually going to, there are 2 things that I'm sure you are going to meet in the industry. And these 2 things are actually sort of advanced. DI with Dagger and RX Java. And they can actually be a whole lot of headache. They have like this steep learning curve. I included it because I know this is something you are going to meet in the industry. So they are actually sort of super important. So what I would say is you should start learning DI as soon as you are comfortable with creating a very simple Android application. Like you've gone through this process, this initial Android baptism of you can set up an activity, you can make an API call, you can show some things on the screen, your click listeners are working, so it's sort of like the next level. So once you are done with the basics, I would say that is when you should start considering picking up DI.
Okay. Thank you very much for that. Then second is, when is it preferred to use dependent components over subcomponents? Or is subcomponents just an improved way of performing dependent components? Or I would say maybe person meant making use of dependent components.
Yeah, I understand what the question is. So what I would say is this. So if you don't need your component to depend on several others, so you have a component and you don't need to depend on more than one component, always go for subcomponents, because with subcomponents, Dagger generates a better code, a much more optimized code, because your subcomponent is living inside your parent component. So once you're not sort of having this, I need a component that I have to depend on some other components, always go for subcomponents.
All right. All right, thank you very much. The next is, can an app have multiple component interfaces?
Yeah, of course it can, but maybe I would assume the person that asked that question is asking if the app can have more than one, maybe main component. No, it can't. You can only have just a single main component, at least from my experience. It's usually the case. You have just one single main component, one single entry point. Maybe it's possible for you to have these different components, but probably in different source sets, right? You have one main component for your main source set. Maybe in your Android test source set for your Espresso test, you have another main component. Then maybe for your roboelectric test, you probably create another component. So for these different source sets, you can have different main component. But for your main application, for the one that goes into production, your main source set, you only need one main component. Then you can have sub-components or dependent components.
Okay.
Yeah.
All right. Thank you very much for that. Next is, if I have projects already set up without DI, already in production, do you advise implementing DI into it or just wait for a new project?
It's so for learning purpose. So it depends on what the project, or irrespective of what kind of project it is. So even if it's an app you already have in the App Store, try to use, if you want to use it to learn, you can also use that same app to learn. If it's probably you're working for a company and maybe the version of your app that's in production right now does not have DI, push for including DI into it, because as the thing scales, your app is going to DI is going to help your application to scale properly. So it doesn't matter whether it's an app that is owned by a company that's even already generating money, something that you're using for just a test, it's your own app. You're just using it to learn things. Pick it up and include DI.
Okay.
Don't wait for a new project.
I have two more. One asked, in your slide, I noticed you passed main activity as a parameter to your inject method. Can you please explain why?
Yeah, because I want to use that inject into the main activity. Because in most cases, probably in your main activity or in your activity, basically, you are going to have some fields. Maybe the activity needs to use shared preferences, or the activity needs to use, maybe the activity from the activity you are making an API call and you need to inject retrofit. Because you don't have access to the activity, you cannot use constructor injection, right? So you need to perform field injection. So which means in your component, you need to declare a function that takes an instance of your activity. So that when you get into your activity, in your activity on create, you can now get an instance of that component, maybe app component. You can now call that function app component dot inject. Then you pass the instance of your activity dot inject. In most cases, you just see this, or main activity dot this, or whatever your activity name dot is, what this. And what Dagger does at that point is to inject those fields, those at inject, that you have those fields that you have. Dagger tries to inject them to actually, pass the real bindings into them. So it's why I have that function in my component to perform field injection into those components that I don't have access to.
All right. There was a question by someone here saying, please give an example of field injection. Well, I think that should answer that question. So that's why I didn't bring that up. But
already sort of cover it, right? So there are two ways to inject into things. For classes that you own, that you are writing, well, we know about constructors, right? And we know that our constructor can take some things, some parameters. So you can just annotate that constructor at inject, and that guy is going to supply those things to you when you're constructing that your class. But for field injection, for things that you don't, a field is just a field. Like, I think we understand what the field is in Java Kotlin, like an instance variable, something that you declare inside the body of your class. It's a field. It's a property. Yeah. So it's a property. But that property, it is not something that you own. It's something that you want, that you want injected. So it's a field, something that you declare inside the body of your class. You can actually annotate that property at inject, and Dagger is going to supply that thing to you. That is what field injection is. It's different from, it's not in the constructor, it's in the body of your class.
Okay. So someone just asked an important question now. In my multi-module app, I have components in each of the module. Is this a bad practice?
No, it's not. It's not a bad practice. So I guess each the component that you have in each of these modules, they're probably scoped to that module. They don't have this. They don't have a singleton scope, and you actually get these components from your main components. Like it's really not it's not a bad practice at all. Basically, that's just it. So it actually sort of makes sense really to have each component have their own, each module they have their own modules that provide dependencies for them. They can also, in most cases, or in some cases as well, they can also have their own component that module is tied to that component. Then the component is in turn used by the main component. So from main component, you can get an instance of that subcomponent that you use in that module. So it's really not a bad practice, basically.
Okay. Last two. I'll just ask them together so we don't have to go back to them. The first is, would you advise just escaping to coin? Then the second is, you're shaking your head, Mike. Would you advise just escaping to coin? Then the second being, what's the best approach of learning DI? Meaning, what recommendation can you provide?
Escaping into coin. Don't escape. Why are you running to? Coin is not DI. We want to drag me into service located DI. See, well, if I don't. Have I looked at coin? Maybe coin is not really a DI. It's a service locator. But if it works for you, fine. For smaller projects, you can use coin. And now that we have ILT can actually help you do the same thing that coin would have. The same, you don't have to do all the groundwork. You don't have to create, components, modules, all these boilerplates thing. With ILT, you can actually, do the same thing whilst having the benefit of Dagger. Dagger scales better. It's one thing. For really, I've never really worked in a huge code base or a very large code base that uses all these coin and these Kotlin things. It's usually Dagger. So Dagger scales better for very, very huge app. Or for a small app, of course, you can use things like coin. And how to learn, like you've already taken the first step, by attending this talk. So I'm sure there's probably one or two things that you might have picked up from this talk. You just need to go back and try to see how much of them you can implement. Just start a very small project, a small thing, probably clicking a button and showing something on the screen, and try to put there and try to just use a component that injects, like a very basic thing. So, you've already attended the talk, you've tried to practice. Some of these links too are good. There's a code lab. I'm sure Google has a code lab on Dagger that you can also try your hands on. So it's basically more practice. Try to apply some of the things you're learning. So,
okay.
Yeah.
And thank you very much, Samir. Michael, please, you have to talk.
Yeah, so about the coin thing, I just wanted to add something. I was laughing because so we started this app at a proof of concept, like a small thing. So I thought about all the going to set up Dagger and everything, and I just said, no, I'll just use coin. So we opted for coin at the time, and then we proved the concept, and then management was like, yeah, let's build it for real. So they started adding features, like loading features into it, and then after a while, we realized that you keep going back to the module file, like to the modules to specify like the injection points for every single class you add. And then it's annoying because you keep having to write this get function. So you write get like everywhere, just to specify the dependencies that you're supplying to a particular class. And it gets annoying because that file is like 500 lines now. And if you look at it, all you see is get everywhere. And it's very, 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 very annoying. And it doesn't scale properly because you have to keep going back to add each line, like when you add a new class. With Dagger, all we have needed to do was to specify the providers, and once we write inject, it will just inject the dependencies. So it's very annoying. And now with Hills coming in, we are now thinking about like just migrating the whole project away from.
All right, that's nice. I think that's a nice perspective. So I mean, I think we can infer from this that Dagger should be the way forward, or like industry standard for everyone, yeah, or for most people. I would like to say thank you very much to Mio Java for anchoring this session and sharing from his wealth of knowledge. Man, we're really grateful, and we should expect more of this going forward.